Alrighty, so this is going on page 143 when we're done. We're going to look at arithmetic versus geometric. So we've already learned all the stuff we need to be able to do for today, but we need to be able to distinguish between the different types of sequences. So I want you to look at just 1, 2, and 3, and I don't care what the instructions say. All I want you to do is look at those sequences, you use your calculator, determine if they are arithmetic, geometric, or neither. Okay, think about how you know the differences. And all I want to know is, are they arithmetic, geometric, or neither for 1, 2, and 3? If you're not sure how to figure that out, look at your notes. 1, 2, and 3. All I want to know is, are they geometric, arithmetic, or neither? But if you can't identify them, then you don't know which formulas to use, right? That's the kind of the whole point. We got to know how to identify it. Most of what you have to apply, and that's a big problem for a lot of you, is that you can do the math and you've got good skills, but you don't know when to use what. So step 1 is almost always identify it as whatever it is, so then you know what to do with it. And that identification process is, your only options are arithmetic, geometric, and neither, not -3. So that you got to know if that's arithmetic, geometric, or neither. You look in your notes. That's what you're supposed to know already. We just did this stuff. How do you identify what makes it an arithmetic or geometric sequence? Arithmetic, geometric, or neither. It's really the first part of the directions. Just determine whether the sequence is arithmetic, geometric, or neither. Just the first sentence is all I want you doing. No skip. What do you look at? What do you look at when you're trying to determine even how to get like the next terms in the sequence, right? You start looking at the pattern. Right, if it has a common difference or if it has a common ratio, think about those. One, 2, and 3, not just number 1. I don't know. 1. Yeah, just write down arithmetic, geometric, or neither. It's not nice. Okay, so let's look at number 1. If you were going to explain the pattern to me, what is happening here with the pattern? Well, multiplying by -3, right? So here, I multiply by -3, multiply by -3. So either that is a common difference or a common ratio. What is it? Common ratio. So our ratio is -3. So is this geometric, arithmetic, or neither? Geometric. If you are multiplying, it is geometric. Okay. So how could you explain number 2 to me? Yeah, exactly. Yeah. There's not really a great mathematical explanation, right? So it's like, yeah, I mean, this would be subtracting 2 and then adding 3 and then subtracting 4. Like it's not one or the other, right? And so this is neither because you can't find a common difference or a common ratio. What is happening in number 3? Okay, we're subtracting 9. So we're minus 9, minus 9. So that's a common difference, which is negative 9, which means it's what? Arithmetic. Okay, you have to be able to identify what you have. So you use, the formulas are stuff I will give you. I'll give you the formulas, but you have to know which ones to use. And if you can't identify them, then you don't know which ones to use. Okay? But you were right. I know. I'm not surprised. That's good. Okay, good job, Eddie. All right, so now that we have a better idea of that, I want you to do the same thing for 4, 5, and 6, but don't write it real big because we're also going to go and calculate that. But I want you to figure them out first. Then we will do what? A letter's fine. Yeah. Well, I mean, when you're answering the question, like for real, the word has to be there. If you want to do a letter for now, in case you think you might be wrong, but Hector, 4, 5, and 6. Come on, figure them out. It's not hard. Stop it. Right. No, it's only multiply. It's multiplication. That's it. Multiplying by a fraction. So how are we going to, let's talk about what to do in number 4 to check it, right? Because it's not one that you might just look at and know. So if it's arithmetic, then I can take this one and subtract the one before it, and then take the third one and subtract the second one, and I should get the same difference, right? Or I can take this one and divide it by the first one, and the third one and divide it by the second one, and then I should get the same ratio, right? That's what you literally do to either figure out if it has a common difference or a common ratio. So does it have a common difference or a common ratio? Common difference. And what is the common difference? 1/2. Okay, so it is a common difference, and that makes it arithmetic, right? Okay, well, hang on. But we're going to actually do the rest of this now. So it says, if arithmetic or geometric, write an explicit formula to find the nth term and find a of 7. So your arithmetic sequence is this right here. I don't know if y'all can see that over there, but I can give your notes out. So it's the a sub n equals d times n minus 1. So I need an a sub n formula that's equal to d, which is 1/2, times n minus 1 plus a sub 1, which is negative 15/4, which I could have written as minus 15/4, but I had already written my plus sign, so I'm going to leave it like that. It doesn't matter either way. I know. So then I need to find, what is it, a7? So it's 7? Is it 7? Yeah. So a7 is going to equal to 1/2 times 7 minus 1 minus 15/4. And then you can type that in your calculator and get your answer. What'd you get, Michael? Good job. Negative 3/4. Yeah, unless there's like a decimal there, you would put it in a fraction. All right, we all good with that? Now on number 5, do you have a common difference? No. Do you have a common ratio? Well, you can't just stare at it. I can't stare at it and tell you for sure. You got to actually do it in your calculator, right? So what is 0.1? The common difference or the? Okay, so you did 2/9 minus 1/10. Okay, and you got 0.1. What do you get when you get 3/8 minus 2/9? Well, you can't just do one of them. Because I could get a ratio there too, but it's not a common one if I don't have it more than once. Does that make sense? So 3/8 and then, what did you say, difference or ratio? He did difference, so what does that give you? 1.75? Okay. So this is not a common difference then, right? And so they're not the same. Oh, 0.75. Okay. Oh, 0.175, sorry. Okay. Well, either way, it's not going to work, so I don't know what it really is, but so that's your difference. That's not a common difference, right? So it's not arithmetic. If you divide, do you get a common ratio? No. So this one's neither. So you got to check both, but you have to check more than just one set of terms. Does that make sense? All right, so this one, maybe we could tell without the calculator, right? So here, remember, you're multiplying. Your common ratio would be what? 1/4. Good. So your first instinct might be, hey, we're dividing by 4, but you have to make that into multiplying by 1/4, which means that it is geometric. So to find our nth term formula, that's this one right here. So A sub n equals A1, which is 320, times times 1/4, sorry. Times 1/4 to the n minus 1 power. So there's your nth term formula. And then we got to find 7, yeah. A7 is equal to 320 times 1/4 to the 7 minus 1 power, which you could write as 6, or at least when you type in your calculator, you can put it that way. But make sure that you are actually putting the 1/4 to the correct exponents. Make sure you have it like in a fraction form and maybe in the parentheses so that you're doing all of that correctly and the calculator likes what you're doing. Good, yes. Yeah, so make sure you get 5/64, because if you don't just copy this down. There's something you're not typing into the calculator correctly, and I want to help you fix that so you're not getting them wrong because of that. Yeah. Actually, I don't, can you see them from over there? Okay. I was going to say, because I might give them to you on a little card too, but if you could see them, I wasn't sure if the board was in the way. All right. Either way, I was going to give them to you, whether I'll leave them up there or give it to you on a little card. All right. Are we good with those? Yes, basically just do it, because you'll have the formulas, because they're all this, they can get very confusing, but you just have to know when to use what. And what so vocabulary is important too, so that when it asks you for certain things, you know what it's asking you for. All right, so let's look at this. It says, determine whether the series is arithmetic or geometric. That's different than a sequence, okay? However, notice the difference between this and number 1. What's in the little curvy brackets? What's the difference between this and what's in number 1? There's plus signs instead of commas. The numbers would be, but the numbers still act the same. Well, that means here we're actually adding them up. But if we want to determine if it's arithmetic or geometric, we're doing it the same way. Like that part doesn't change. So does this have a common difference or a common ratio? Common difference, because I am adding 7, right? Add 7, add 7. So your common difference is 7, right? This is the series. I want the sum of the first 19 terms. Well, that means this is arithmetic. Right? And then it says find the indicated sum. So that's what we have right here. I want S19 equals, let's see, N, which is what? 19, times A1, which is 18, plus, oh, guess what I need that I don't have? I need A19, right? I don't have that. I have A1, I need this, but I can find it, right? All I have to do is use this right here. Well, add 7 19 times, but I'd rather not do that. I can do this right here. My common difference is 7 times 19 minus 1 plus 18. Yeah, I probably should have done that first, but I know that most of the time y'all jump to this stuff and you're like, dang, I don't have that number. Then you have to go back and do it. It's fine. Doesn't matter what order you do it in. You get 144. Good. Okay. So I put plus 144, and then it's all over 2. And then my final answer for the sum of the first 19 terms, let you put that in there. No skip. It's 1539. All right. What questions do you have at this point? All right, look at number 10. Arithmetic or geometric? Geometric? Yes, because you're going to multiply by 5, right? So your common ratio is 5. Oh, it is negative 5. Thank you. Negative 5. Thank you, negative 5. I know. Well, it's equals, that's a negative. All right, so then I have the sum of the first 7 terms. So I'm using this one right here. In this one, I need the first term. I don't need the last term. So I have everything I need at this point. So S7 equals A1, which is 3, times 1 minus negative 5 in parentheses to the 7th power, all over 1 minus a negative 5. Be very diligent with your parentheses so that the negatives get treated correctly. So I'll put the answer up here and make sure that you get this. If you are not getting it, please speak up so that I can come and help you figure out what. I'm sorry. You can. We're good? Yes, yes, thumbs up. Yes, Hector, yes. 1, yes. All right, flip this over. Let's jump to number 14. So I want you to figure out if it is arithmetic or geometric, first of all. Or neither. What? Did you not get that answer? Oh, yeah, and it makes a difference. Oh, yeah. Well, that's all you have to do, though, is arrow back, and then put the parenthesis, and then you're good. That makes sense. If you just arrow to the left, it'll let you go fix it. All right, what is it, arithmetic or geometric? You haven't? Are y'all just waiting for me to tell you? I only asked you to do one. 14. You're guessing. You're just yelling stuff out. How do you know? What's the ratio? Oh, no to 3. Stop it. You either, okay, 2 people at your table need to subtract the first 2 sets of terms, and the other 2 people need to divide and figure it out. Y'all determine who's who. It's not neither. That wasn't even part of the directions. It's one or the other, and don't just guess. If you're just guessing, then I don't know that you know how to actually figure it out. Okay, but you have to do the first 2, and then you do 2 and 3 so that you can compare them. Does that make sense? I'm at 2 of you need to subtract this, and 2 of you need to divide and divide. It's not arithmetic. That's what he says. Oh, good Lord, people. Okay, look at this. We're going to do, because I'm not convinced that y'all know what the heck you're doing. Okay? So we're going to do a fraction and a fraction. And I'm going to take 56 over 15. And then I'm going to divide that by 12 over 5. So that gives me, if I divide, that means that this would be multiplying by 14 ninths, right? So then I got to check this one. And I'm going to do 76 over 15 divided by 56 over 15. That's what you got 4/3 for. I get 19/14. Okay, so are those two the same? No. Okay, so that means it is not geometric. So then, well, then now I'm going to, I was checking the geometric. Now I'm going to check the other. And if I do 56 over 15 minus 12 over 5, I get 4/3. So this is adding 4/3. But by itself doesn't mean anything. I got to do the next one. 76 divided by 15 minus 56 divided by 15. And I get 4/3. Okay, so that gives me a common difference. It's 4/3. Make sense? Because you got to know how to check them. So now that we have that, phew. All right. You don't get to make up your own numbers. All right, so here's what we need. Focus. In order to find this, we have to have a sub 1, which we have, right? A1 is 12/5. We have to have A13 also, which means to find that, that's equal to the common difference, just 4/3, times 13 minus 1, plus 12/5, because I need that number. Yeah, I have to have, for the arithmetic, you have to have the first and the last. I'm making my head hurt. No skipping. Yeah, what's the fraction, though? How about 236 over 15? Maybe, well, let me make sure that this, what I have on the paper is right. Yeah, why don't we all actually do it? Okay, maybe what I have down here is wrong. I know. No, that one won't simplify, though. It's 92 over 5. Okay. Yeah, I didn't, because I worked some of them, I didn't work them all out. I know, I'm cheating again, and it's messing me up. Okay, so it's 92 over 5. I know. Do as I say, not as I do. That's what my daddy always said. All right. So now I want the sum of the arithmetic series. So I use this one. And the sum of the first 13 terms is n, which is 13, times 4/3 plus 92/5 all over 2. And I will work that out again as well, just to make sure. I got, what'd you get? I got 1924 over 15. Yeah? Are you making up numbers? All right. Oh, wait. What did I use 4/3 for? What the heck? Oh, crap. Oh, my Lord, what is wrong with me? I used the common difference. I didn't use A1. Jesus. Sorry, no, I know I'm recording. It's okay. I'm not perfect. Oh, my Lord. Okay, look. Well, guys, y'all just stop talking. This is supposed to be A1 plus AN, and I'm supposed to use these two numbers, and that is not what I did. So you did it right. It was 12/5. Good Lord. But here's the good thing about these calculators. If I just arrow back to the left, I can change my 4/3 to 12/5, and I don't have to retype all that mess in. I know. I'm sorry. Y'all deserve a better teacher, but you're stuck with me, so. Okay. All right, here we go. 676/5. Goodness gracious, I'm so sorry that I don't want to make it confusing. All right, how are we doing? Yeah, next time I'll work it out myself. Well, actually, that's not even, I can't even blame that mistake on that. All right, let's look at 15. It says, determine whether the series is arithmetic or geometric, then find the sum. It's way easier when you are given this. And it doesn't even say arithmetic, geometric, or neither. It says arithmetic or geometric. This does not have an exponent. So what is it? Arithmetic. This does, because it looks like this. So what is this? Geometric. Make sense? Easy enough? Okay. So let's see, we're going to do number 15 on this. We'll do 15, and then we'll skip 16, and we'll do another one. All right, so it's arithmetic. In order for me to find this sum, I'm using this one, and I'm going to use it correct this time. The things I need n. What is n here? 28. I need the first term, which I'm going to have to find out, right? So I'm going to have to substitute 1 in, and when I do that, I'm going to get A1 is equal to 23 minus 6 times 1, which is 17. And then I also, so this is 17, then I also need A28. So it's going to be 23 minus 6 times 28. Tell me what you get there. Negative 145? That's good. All right, so these are the three things that I need, right? Then I'm going to put it in that formula. So S of n is equal to, or S28. Okay, 28 is equal to n, which is 28 times A1, which is, I'm going to use this right this time, 17 plus a negative 145 all over 2. So the sum of the first 28 terms then. Well, here, I won't do this again because that is not what my paper says, but I trust nothing anymore. Okay, yeah, okay. Negative 1792. Yeah, that's what I got too. Or that's what somebody got. What questions do you have? Anything? All right. So look at 17. Is it arithmetic or geometric? Arithmetic. Y'all agree with that? Yes. And if the directions don't say or either, then okay, that's it. I can't spell it right though. So arithmetic. Okay, what about 18? Geometric. Okay, so we're going to do 18. And we're looking for the sum, so I'm using the sum of the series here. For this, I need A1, and I need N, and I need R, right? What is R? Negative 1/4, right? What is N? It's 5. Subtract 3 and add 1, it is 5. So when I say I want A1, do I really want A1? Not really. What do I really want? 3, A3, right? So I need to find that. A3 is going to be equal to 20/3 times negative 1/4 to the 3 minus 1 power. So I will do that also to make sure. Times negative 1/4 squared. Yeah, I got 5/12, so I agree with that. Okay. So here are the things that I needed. I needed A3, because it really was A1, but because we start with 3, that's why we changed that, and here's what I have. Then we're using this geometric series over here. So the sum of that we're finding, I'm not even going to put a number there because it's not really the first 7 terms. It's the first 5 terms, or not even the first 5 terms. And that's equal to A1, which is A3, which is 5/12, times 1 minus -1/4. And then N is 5 all over 1 minus a -1/4. So lots of fractions and parentheses there. Be very careful when you're typing that in. But the fraction and the fraction on this calculator, I think, is just amazing. Yes. Sure does. I like how you have no confidence. You say a word. Okay, I have a crazy number. Yeah. But remember, you can always arrow back. Like, don't clear it off. You can always go fix whatever is weird. But I get 1025 over 3072. And remember, you have to close the parentheses on the fractions. It doesn't like it if you don't do that. And be careful after you do an exponent that you arrow to the right so it drops it down and you're not like closing the parentheses on the exponent. So if you're getting errors, let me know. Let me look at it. I could probably tell you real quickly what the issue is. But make sure you get this number. Okay. All right. Anybody need me to look at their calculator? Speak now. It's all good. None of us are perfect. Me, clearly. Okay. Oh, you have plus 1/4 right here, hon. You can't make that minus a negative because that's in parentheses. You have to take that to the exponent before you can do that. Does that make sense? All right. Anybody else? All right. 2 more. These are going to go quick. Number 19, arithmetic or geometric? Geometric, right? All right, so look at what we want. We want the sum from 1 to infinity. So an infinite series has to be convergent. How do we tell if it's convergent or divergent? Right, well, that's what they mean, but like, how do you tell by looking if it's one? Good. Right here, this is what the absolute value of this is 1/5. So it's less than 1. So is it convergent or divergent? Convergent. This has to be, the absolute value has to be less than 1. Good guess. So since it's convergent, I get to actually find the sum, and this is what we're using right here. In order to do that, you have to have A1. So we're going to find that, we have to find that -7/4 times -1/5 to the 1 minus 1 power. What's 1 minus 1? 0. What's anything to the 0 power? 1. So this is really just -7/4 because that's A1 in that formula anyway, by the way. We didn't. But y'all would have because you didn't know that that was A1. But if you know your formulas, I know. But nobody stopped me. That's why I'm saying you don't have to do this. It's okay. I know. A1 is -7/4. But I also wanted to show you that if you didn't realize that, once you do it, you're still going to get that same answer. But sometimes you feel like weird stuff's happening. That's why it's happening. Okay? And then we also need R. What's R here? -1/5. All right, so we do S is equal to A1, which is -7/4 times 1 over 1 minus a -1/5. It's the infinite, so we have to use this one. Because we can't, n is not anything we can use. just glad he's doing it. Y'all leave him alone. No, yeah, see? Good job. It is negative 35 over 24. Very good, Hector. Appreciate you participating. Everybody good? Punching buttons correctly? Okay, don't be lying to me because I won't know. I want to make sure you know what you're doing. All right, look at number 20. Geometric or arithmetic? Geometric. Okay, so this is, we're going to infinity. Is this convergent or divergent? Divergent, because this is greater than 1, so it's divergent, and we can't find the sum. There's no sum. Right, because there isn't one. That's why we can't find it. All right, what questions do you have? We're good? So for now, you're going to have your notes handy so you can make sure you use these formulas correctly, right? And make sure you can identify them so that you're doing the right thing at the right time, okay?